Arthur Eddington, a renowned British astronomer, physicist, and mathematician, was one of the pivotal figures of the early 20th century in the field of theoretical physics. His work, particularly his support of Albert Einstein's general theory of relativity, placed him at the forefront of groundbreaking scientific advancement. Beyond his scientific contributions, Eddington's life and philosophy provide valuable lessons that transcend academia and can be applied to various aspects of our personal and professional lives. These lessons are rooted in his unwavering curiosity, resilience in the face of adversity, dedication to intellectual integrity, and openness to new ideas. This video will explore the key life lessons drawn from Eddington's career and personal philosophy, shedding light on how his approach to science and life continues to inspire individuals across disciplines. I. Curiosity and the pursuit of knowledge. A. The role of curiosity in scientific discovery. Eddington's fascination with the universe. As a young boy, Eddington exhibited a deep interest in understanding how the world and the cosmos worked. He once said, "The universe is not only queerer than we suppose, but queerer than we can suppose." This reflects his openness to the mysteries of the universe and his belief that curiosity was key to unraveling those mysteries. Curiosity as a driving force in his career, Eddington's relentless pursuit of knowledge led him to study various fields of physics and astronomy. His curiosity was the catalyst for much of his groundbreaking work, especially in understanding the nature of light, the theory of relativity, and quantum mechanics. He was not merely interested in finding answers but also in asking the right questions that could open doors to deeper understanding. B. Lessons in encouraging curiosity. The importance of lifelong learning. Eddington's life teaches us the value of maintaining a sense of wonder and curiosity about the world throughout our lives. This lesson emphasizes the importance of seeking knowledge not just for career advancement, but for personal growth and understanding. Questioning assumptions. Eddington's willingness to question established scientific dogma, such as Newtonian physics, in light of Einstein's new ideas exemplifies the necessity of curiosity in pushing the boundaries of human understanding. 2. Embrace of new ideas and openness to change. A. Eddington's role in the acceptance of Einstein's theory. The context of Eddington's work on relativity. When Einstein first proposed his theory of relativity, it was met with skepticism by many in the scientific community. Eddington, however, was one of the first to recognize its potential and the importance of empirical validation. His famous 1919 solar eclipse expedition, which demonstrated the bending of light by gravity, helped confirm Einstein's predictions and brought relativity into the mainstream. Challenges in accepting new ideas. Eddington's acceptance of Einstein's theories was not without its own difficulties. Many of his colleagues were not yet convinced of the validity of relativity. But Eddington's faith in the power of new scientific ideas and the evidence that supported them demonstrated how important it is to stay open to transformative changes in our thinking. B. Lessons on openness to new ideas. Breaking from tradition. Eddington's willingness to embrace new, revolutionary ideas teaches us that innovation often comes from those who are not afraid to challenge the status quo. This mindset can be applied not only in science but in any field where progress depends on new ways of thinking. The need for critical evaluation, while embracing new ideas is essential, Eddington's story also teaches us the importance of careful scrutiny and empirical verification. New ideas should be tested and proven, rather than accepted blindly. 3. Collaboration and the collective effort. A. The importance of teamwork in scientific discoveries. The solar eclipse expedition. Eddington's expedition to measure the bending of starlight during the 1919 solar eclipse was a monumental scientific achievement. However, the success of the project was not solely due to Eddington's efforts but also the collaborative work of the team involved. Astronomers and scientists from different locations work together to gather data and ensure the accuracy of the measurements. Collaboration with Einstein. Eddington's relationship with Einstein highlights the importance of intellectual collaboration. Although the two men never met in person, their mutual respect for each other's work forged a connection that helped advance our understanding of the universe. B. Lessons in collaborative success. Learning from others. Eddington's story teaches us that no great achievement is accomplished in isolation. We must be willing to learn from others, work together, and value the expertise and perspectives that different individuals bring to the table. Fostering a team mentality. Eddington's success demonstrates that fostering a culture of collaboration rather than competition can lead to more significant breakthroughs. In our own work, embracing collective effort can lead to more diverse and robust solutions. 4. Perseverance in the face of skepticism and adversity. A. Eddington's challenges and resilience. Skepticism surrounding Einstein's theory. Despite the groundbreaking nature of Einstein's theory of relativity, many scientists remained skeptical, and Eddington faced resistance in his efforts to validate it. The eclipse experiment itself was fraught with challenges, including difficult weather conditions and the logistical difficulties of the observational setups. Perseverance despite difficulties. Eddington's determination to push forward with the experiment despite these obstacles showed his unwavering commitment to scientific progress. His work in confirming Einstein's theory was a testament to the importance of perseverance when faced with resistance and adversity. B. Lessons on resilience and determination. Overcoming doubt. Eddington's perseverance teaches us that when we believe in the validity of an idea or a cause, we must remain determined in the face of doubt, whether it comes from external criticism or internal uncertainty. Great achievements often require pushing through setbacks and skepticism. Adapting to adversity. Eddington's life also shows us how to adapt in difficult situations. His ability to navigate the challenges of his solar eclipse experiment, where factors like weather and equipment failure threatened the mission's success, reflects his resilience and ability to adapt to changing circumstances. V. Intellectual integrity and the quest for truth. A. Eddington's commitment to scientific integrity. Dedication to truth. One of the hallmarks of Eddington's career was his unwavering commitment to intellectual honesty. He valued the pursuit of truth above all else, even when it meant challenging his colleagues or facing criticism. This commitment was especially evident when he defended Einstein's theory of relativity, even when many in the scientific community were unconvinced. Ethical considerations in science. Eddington believed that science was not just about finding answers but doing so with integrity. His work exemplifies the notion that scientific inquiry should be grounded in the search for truth, without succumbing to personal or political biases. B. Lessons in intellectual integrity. The importance of honesty. Eddington's dedication to honesty and the scientific method teaches us that integrity should always guide our work, whether in scientific research, business, or personal endeavors. Upholding ethical standards is crucial for maintaining trust and credibility. The value of independent thought. Eddington's ability to independently evaluate scientific theories, such as Einstein's relativity, reminds us of the importance of critical thinking and the willingness to challenge conventional wisdom when the facts demand it. 6. The interplay between science and philosophy. A. Eddington's philosophical approach to science. Science and philosophy intertwined. Eddington was not just a scientist but also a philosopher. He believed that science and philosophy were closely linked and that science should be grounded in philosophical inquiry. His reflections on the nature of reality, the limits of human knowledge, and the role of perception in understanding the universe highlight the importance of philosophy in the scientific process. Understanding the limits of knowledge. Eddington often acknowledged that while science can explain much about the natural world, there are inherent limitations to human knowledge. He once said, "The true value of a theory is not that it has been experimentally verified, but that it fits into the grand scheme of things." This suggests that, while science provides powerful tools to understand the world, it is always part of a larger, more complex framework. B. Lessons from Eddington's philosophical insights. The value of intellectual humility. Eddington's recognition of the limits of scientific knowledge encourages intellectual humility. We should always approach new knowledge with an understanding that what we know today may be incomplete, and there is always more to learn. Bridging disciplines. Eddington's life reminds us that the best thinkers are those who draw from a wide range of disciplines, blending science with philosophy, and applying critical thinking across domains to create a more holistic understanding of the world. 7. The role of patience in scientific discovery. A. Eddington's long-term commitment to ideas. Slow acceptance of relativity. Eddington's dedication to Einstein's theory of relativity is a prime example of the role patience plays in scientific discovery. While Einstein's theory was not immediately embraced by the scientific community, Eddington remained patient, waiting for the right opportunity to gather concrete evidence. The 1919 solar eclipse, which provided the crucial observational data, was a moment years in the making. Scientific progress takes time. Eddington understood that true scientific breakthroughs often require years, if not decades, of preparation, testing, and verification. His patience is a reminder that not all great ideas are immediately accepted, and sometimes it takes time for the world to catch up with groundbreaking concepts. B. Lessons in patience. Endurance in pursuit of knowledge. Eddington's example teaches us the importance of persistence in the face of slow progress. Scientific discoveries, like many personal and professional achievements, require patience and long-term commitment. It is important not to rush the process but to allow ideas to develop and mature over time. Trusting the process. In both scientific endeavors and other fields of life, Eddington's life suggests that we must trust the process. Breakthroughs do not happen overnight, and the time spent working and waiting for results is as valuable as the discovery itself. 8. The intersection of faith and science. A. Eddington's own belief system. Eddington's religious views. Although Eddington was a committed scientist, he was also a deeply philosophical person with a spiritual side. He often reflected on the relationship between science and faith, suggesting that both are pathways to understanding the mysteries of the universe. Eddington believed that science and religion could coexist, with each providing different ways to explore and understand the world. Personal belief in the harmony of nature. His understanding of the universe was influenced by a sense of wonder and reverence. Eddington famously wrote that, "The universe is a machine for the making of mind," indicating that he saw a deep, almost spiritual purpose in the way the cosmos was ordered. B. Lessons from the faith-science relationship. Balancing skepticism and wonder. Eddington's ability to maintain both a scientific skepticism and a sense of wonder about the universe serves as a powerful lesson in balancing rational inquiry with openness to awe and reverence. He exemplifies that a truly complete understanding of the world requires both intellectual rigor and a sense of humility in the face of mystery. Understanding the coexistence of different perspectives, Eddington's approach suggests that science and faith do not necessarily have to be in conflict. We can approach life and the universe with both scientific inquiry and personal beliefs, recognizing that both provide different, complementary ways of seeking truth. 9. The importance of communication in science. A. Eddington's ability to convey complex ideas. Public outreach. Eddington was not only a scientist in his laboratory but also a skilled communicator. He wrote extensively for both scientific and popular audiences, making complex ideas more accessible. His ability to communicate Einstein's theory of relativity to the public played a crucial role in its acceptance. He understood that the power of science lies not only in discovery but also in the effective sharing of knowledge. Explaining complex phenomena, whether through his writing or his public lectures, Eddington had a gift for breaking down complicated concepts and explaining them in ways that ordinary people could understand. His efforts to popularize science made him a bridge between the scientific community and the public. B. Lessons on communication and impact. The necessity of clear communication. Eddington's example teaches us that in any field of expertise, being able to communicate ideas effectively is crucial. Whether you're in academia, business, or the arts, your ability to convey complex thoughts to a wider audience can determine the impact of your work. Teaching and sharing knowledge. Eddington's outreach reminds us that the true value of knowledge is not just in acquiring it but in passing it on. Educating others, sharing insights, and making complex ideas accessible to non-experts can have a lasting impact on society. X. The value of understanding the bigger picture. A. Eddington's perspective on the cosmos. Seeing beyond the immediate, Eddington was deeply committed to understanding the universe in its grandest form. He was interested not only in the details of his specific research but also in how his findings fit into the broader understanding of the universe. His philosophy about the interconnectedness of all things reflects a holistic approach to knowledge. The implications of relativity. Eddington's work on Einstein's relativity helped change our understanding of space, time, and the universe itself. He was fascinated by the philosophical implications of relativity, including the way it challenged our notions of reality. His ability to see beyond the immediate impact of his work shows how important it is to understand the long-term consequences of scientific discoveries. B. Lessons from a holistic perspective. Thinking long-term, Eddington's approach reminds us of the value of seeing beyond immediate goals. Whether in business, personal development, or any other area, understanding the broader implications of our actions can help guide us toward more meaningful outcomes. Integrating different areas of knowledge. Eddington's holistic view teaches us that the best innovations often come from connecting different disciplines and perspectives. By understanding the larger picture, we can contribute to more integrated and sustainable solutions to global problems. Conclusion. Arthur Eddington's life and work serve as a beacon of inspiration for those who seek to understand the world around them and to contribute meaningfully to the fields of science and beyond. His curiosity, perseverance, intellectual integrity, openness to new ideas, and appreciation for the interconnectedness of science and philosophy provide invaluable lessons for anyone striving to navigate the complexities of life and knowledge. By embodying these principles in our own lives, we can approach our own work with a renewed sense of purpose, resilience, and dedication to the truth.